Welcome to my presentation. In this presentation, let us try to solve an example using Cramer's rule. In this example, we'll pick a system of linear equations. Cramer's rule. We can use Cramer's rule to solve system of linear equations in 2 variables or 3 variables or n variables. So, in this example, I have picked a system of linear equations in 2 variables, and let the 2 equations be as follows: x1 plus 2x2 is equal to 5. This is equation number 1. And then the second equation is negative x2 plus negative x1. There should be x1. Negative x1 plus x2. I want to be consistent with the color here. Negative x1 plus x2 is equal to 1. So this is equation number 2. So let us try to use the Cramer's rule to solve this problem. So in step number 1, we're going to write the augmented matrix for the given system of linear equations. The coefficient of x1 is 1, the coefficient of x2 is 2, the constant term is 5 in the first equation. The coefficient of x1 is negative 1, the coefficient of x2 is 1, and the constant term is 1 in the second equation. So we'll put a partition line between the constant terms and the coefficient matrix. So that is our augmented matrix. In step 2, we will start to apply the Cramer's rule, and then in here to solve for x1, we can write this as follows. We're going to pick the determinant in the numerator and then replace the first column by the constant terms. So in here, instead of 1, negative 1, we're going to replace that by 5 and 1. We're going to keep the second elements of the column the same, which is 2 and 1. That is the numerator determinant, and in the denominator, that will be the determinant of the original matrix. That will be the coefficient matrix basically, and that is 1, 2, negative 1, and 1. So we can come back and then expand this, and we should be able to find the value of x. So we know how to find the determinants. We're going to we multiply the numerators, multiply the elements along the major diagonal, multiply the elements along the minor diagonal, and then subtract one from the other. So 5 times 1 is 5. 5 times 1 minus 1 times 2. That is what the numerator is. In the denominator, we have 1 times 1 minus negative 1 times 2, isn't it? So therefore, when we simplify this is going to be 5 times 1 is 5 minus 1 times 2 is 2 divided by 1 times 1 is 1. Negative 1 times 2 is negative 2. Negative 2 times negative is a positive 2. Therefore, this comes out as equal to 5 minus 2 is 3, and then divided by 1 plus 2 is 3, and therefore the value is equal to 1. Therefore, the value of x1 is equal to 1. So by using Cramer's rule, we were able to find the value of one of the variables. So we'll use the same method to find the value of x2 as well. Let me call that as step number 3. Okay. In here, if we want to find the value of x2, we're going to, in the numerator part, we're going to replace the second column elements by the constant terms, and then to do that, we'll retain the first column elements because we already found the value of x1, so we don't want to change that. In the second column, we're going to replace the elements 2, 1 by the constant terms, which are 5 and 1. And I'm writing that by a different color, so you see the distinction as to what we are doing here. The denominator matrix, the denominator determinant will be the same. That will be the coefficient matrix, coefficient of the original matrix. So that will be 1, 2, negative 1, and 1. So when we expand this, this is going to come out as follows. We have 1 times 1, which is in the numerator part, minus of negative 1 times 5, like that. And in the denominator, since that we've already found the determinant of that, which is 3 from this part here, I'm going to put a circle around this, that way you see that is the value we have here. So we're going to use that, and therefore I need not have to calculate it again. So that value is 3, so I'll just bring it down as 3 there, and therefore when I simplify the numerator, it simplifies as follows. 1 times 1 is 1, minus negative 1 times 5 is negative 5, negative 5 times negative is a positive 5, and then divided by 3. So 1 plus 5 is 6 divided by 3, and therefore the value is going to be equal to 2. Therefore the value of x2 is equal to 2. So we got the values of x1 and x2. So if we were to make sure that whether these values are correct or not correct, we can go back and then check our work. The way to check it is as follows. We take the original equations and then substitute the values of x1 and x2 in them, and see whether the value what we have on the left hand side comes out same as the value what we have on the right hand side. So let's take equation number 1. Equation number 1 is x1. This procedure here, what I'm explaining here is the check. Okay. So we take equation number 1, which is x1 plus 2x2 is equal to 5, isn't it? So x1 is 1 plus 2 times x2 is 2, that should equal to 5. So 1 plus 4, that should equal to 5. So 1 plus 4 is indeed equal to 5. That is equal to 5. Therefore the left hand side is exactly equal to the right hand side. And we can also satisfy the second equation similarly. And then in the second equation we have negative x1 plus x2 is equal to 1. x1 is 1, negative 1, plus x2 is 2, that should equal to 1. Negative 1 plus 2 is 1, that is exactly equal to what we have on the right hand side. Therefore the left hand value is exactly equal to the right hand value, and therefore the values of x1 and x2 what we have obtained are exactly correct. The solution therefore is x1 equals to 1 and then x2 is equal to 2. So using Cramer's rule, we should be able to solve a system of linear equations in a much more effective manner using determinants. In my next presentation, we shall look at some more examples to see how we can use Cramer's rule to solve system of linear equations.